All right, welcome back to Calculus with Mr. Robeson. Today we're taking a look at some more derivative rules, specifically the product rule. Then we're going to apply it to tangent lines. All right, so we're not going to try and derive this. We could using the limit definition of derivative, but it's just easier if we just try and memorize this. So I'm going to call this our first function. I'm going to call this our second function. All right, and we are multiplying them together. So they're each something with x's. X is the variable. So the way we find the derivative of the product of these two functions is it's the first times the derivative of the second plus the second times the derivative of the first. So we just kind of take turns. Like one function stays the same, the other one becomes the derivative. The other function stays the same, and then the other one becomes the derivative. And we're just adding them together. So we do end up adding here when we do the product rule. All right, so let's try this on these two examples here. So the first one, we're going to try and do this two different ways. Once using the product rule, once by factoring. So here is our first function. Here is our second function. All right, so the product rule says that the derivative of h, which is h prime of x, will be the first guy, so we keep him the same, 3x minus 2x squared, times the derivative of the second guy. So we want to find the derivative of this. Derivative of 5 is 0, because it's a constant. Derivative of 4x is just 4. Then plus the second stays the same. And then we multiply by the derivative of the first. So derivative of the first, derivative of 3x is just 3, minus derivative of 2x squared, we bring down the 2. 2 times 2 is 4. X to the 1 less exponent. So that gives us 4x to the first. All right, now we just have to do some simplifying. So we can distribute the 4 here. So we're going to get 12x minus 8x squared. Here we're going to have to FOIL. So 5 times 3 is 15. We're going to get a plus 12x and a minus 20x for the inners and the outers. So that's going to give us a minus 8x. And then the last, 4x minus 4x gives us negative 16x squared. And then we're looking to combine some like terms. So we'll start with these x squareds. We've got negative 8 of them and negative 16. So that's negative 24x squared. Next, we've got 12x and a minus 8x. So 12 minus 8 gives us 4. So we get 4x's. And finally, all that's left is a plus 15. So that's doing it one way. So that's doing the product rule. The other option we had here is we could have multiplied this out first and then take the derivative. So let's see if we get the same answer if we multiply it out first. So we're going to FOIL. So 3x times 5 is 15x. Then we're going to have outer. So 3x times 4x is plus, let's see, that's going to be 12x squared. Inners, we're going to have a negative 2x squared times 5 is a negative 10x squared. And then last, negative 2x squared and times a 4x gives us minus 8x to the third. These two middle guys, we can combine them. 12 of them minus 10 of them leave us with 2x squared. All right. And now if we take the derivative here, just using the regular old power rule, 15x, its derivative is 15. Derivative of 2x squared, we bring down the 2, we get 4 and x to the first. Minus, bring down the 3, 8 times 3 is 24. X to the 1 less exponent, squared. So we get a negative 24x squared right there. We got a plus 4x right there. And we've got a positive 15 right there. So both ways we got the exact same answer. So if it's polynomial functions like this, you can do it either way. But for now, we're practicing the product rule. So try and do it using the product rule. All right, let's take a look at the other guy over here. So it involves some trig functions. So we have to group it into two parts. So I'm going to say 3x squared is one part and sine of x is the other. So this is my first and this is my second. All right, so now the derivative here, f is our function. So f prime is the derivative. So it's first times derivative of second. So 3x squared times the derivative of sine. Derivative of sine is cosine, positive cosine. Remember, because the sine function is going up and cosine's at positive 1 to start. Plus the second, sine of x times derivative of the first. Derivative of 3x squared, we bring down the 2. We get 6x to the 1 less exponent, so to the first. All right, we can leave our answer like that, or we can try and factor out some x's. Anything's fine with me, really. I'm perfectly okay with this. If we want to factor out some stuff, we can pull out a 3x from both of them. And we'll be left with x times cosine of x plus, let's see, we pulled out a 3, we pulled out the x, so we're left with 2 sine of x. All right, and we can leave it like that too. Either one's fine. Just practicing our simplifying. All right, so that's how we do the product rule. First times derivative of the second plus second times the derivative of the first. All right, so here's an example. Go ahead and pause it, give it a try. All right, so I'm going to say that x squared is my first, and cosine of x, the other thing with an x, is the second function here. Second expression, I guess, is probably a better term. So it's the derivative of f is f prime of x is first times the derivative of cosine. Derivative of cosine comes down, so it's negative sine of x plus the second times the derivative of the first, derivative of x squared. We just bring down the 2, and we get x to the first, like that. And let's see, we can bring the negative out front here, negative x squared times the sine of x. And usually we write the coefficient and the x's in front of the cosine, or in front of any trig function, really. So 2x times cosine of x is usually how we'd write that. It's not wrong to write it like this, but usually we write it like that. And do we have that as an answer choice? Looks like we do. Looks like that's option B. Yep, there it is. All right, so now that we know how to take the derivative using the product rule, we can take the derivative of all sorts of fun functions, and we can apply it to finding the slope of the tangent line when x is a certain value in a particular function. All right, so this guy's got a lot of parts here. So the first part here, we've got two things with x's and they're multiplying. So we can do a product rule here between the 2x and the cosine of x, and we kind of have to. And this is a whole separate thing over here that we have to take the derivative of. So derivative of y, we could say that's dy dx, is first times derivative of cosine plus the second times derivative of the first. And then we just keep going. Minus derivative of sine. Derivative of sine is cosine. All right, now we want to know this when x is pi. So we are going to plug in pi now everywhere for x. So our slope is going to be equal to 2 pi times negative sine of pi plus 2 cosine of pi minus cosine of pi. All right, so I know what the graph of sine looks like. And whenever sine is a value of pi, like right there, pi, it's 0. So this is 0. So this whole term is going away. For cosine, remember that starts high and goes down. Pi is going to be right here. So it looks like that is going to be negative 1. So we're getting 0 from that. 2 times negative 1 is negative 2 minus negative 1. Those two negatives are going to cancel out. So negative 2 plus 1 is negative 1. All right, so find the slope of the tangent line. There's our slope of the tangent line. The slope there is negative 1. All right, next one. I think this is just about it for this section. Find the equation of the tangent line now. So now we want the equation of a tangent line. So now we need a slope and a point. All right, so to get the point, we just plug in. So we take this guy and we plug it in the original function. We'll get y equals pi over 4 quantity squared times the sine of pi over 4 times the cosine of pi over 4. All right, so to find the sine and cosine of pi over 4, I'm just going to draw my little triangle. It's in the first quadrant. Pi over 4 is 45 degrees, so it's 1 square root of 2. This angle up here is also pi over 4. It's isosceles. So sine and cosine are both going to be 1 over the square root of 2. So we're going to get y equals pi squared over 16 times 1 over the square root of 2 times another 1 over the square root of 2. If we put these two guys together, 1 times 1 is 1. Square root of 2 times square root of 2 is 2. So we're getting a 2 on the bottom with the 16 is 32. And on the top, we've got pi squared still. So now we have our point, pi over 4 comma pi squared over 32. Now we need our slope. All right, so now to find our slope, we need to take the derivative of this guy. All right, well, 1, 2, there's 3 different parts here with x. So I'm going to start off by saying that this is my first, and this whole thing here is my second. And then when I have to take the derivative of this guy, I'm going to break this up into 2 different parts again. So our derivative here equals first times the derivative of the second. All right, so now I got to take the derivative of the second. So now, let's see if I can change colors here. Green hasn't been used on this one. So now the sine of x becomes my first, and cosine of x becomes my second. I'm just going to do the derivatives in here. So it's first, so sine of x, times derivative of cosine. Derivative of cosine is negative sine of x, plus the second, cosine of x, times derivative of sine, which is another cosine of x. All right, and now we're back to purple, plus the second, so now we're back to the outside guys in the purple, so that's sine of x, cosine of x, times derivative of the first, and derivative of first is just 2x. So we are adding those 2 guys together. All right, and we want to plug in pi over 4. So we can try and simplify this if we want, or we can just plug in pi over 4. If we just plug in pi over 4 now, we're going to get pi squared over 16. Sine of pi over 4 is 1 over square root of 2. We just found that. Then we've got a negative sine of pi over 4, so negative 1 over the square root of 2, plus cosine, another 1 over square root of 2, times another cosine. So another 1 over the square root of 2, plus sine, 1 over the square root of 2, times cosine, 1 over the square root of 2, times 2x. And remember, x was pi over 4, so 2 times pi over 4. So in here, we're getting negative 1/2 plus 1/2, so that's 0. 0 times that, this whole thing is just 0. So we get 0 plus 1/2 times 2. Those cancel. We're just left with pi over 4 as our slope. So the equation of our line is going to be y minus the y value. So that's pi squared over 32 equals our slope, which happens to be pi over 4 also, then x minus our x value, another pi over 4. That one was a bit of work there, guys. All right, but it can get tricky. We can do product rules inside of product rules. That can happen. All right, so here's another example. This one's a little bit easier. Find the equation of a tangent line to y equals 3x plus 1 times cosine when x equals 0. So go ahead and pause it, try and work it out. All right, so this guy is my first, this guy is my second. We are multiplying those 2 things together. So the derivative, dy dx equals, so I'm finding the slope here, by the way. First, times derivative of cosine, which is negative sine, plus the second, cosine, times derivative of this polynomial guy here. So derivative of 3x plus 1 is just 3. And now we're plugging in 0. So we get 3 times 0, which is 0 plus 1, times sine of 0 is 0. Doesn't matter that it's negative, it's still 0. Cosine of 0 is 1. 1 times 3 gives us 3. So that means our slope is 3. So we've narrowed it down. It's not that guy. It's not that guy. All right, now we need to plug in 0 to get our point. So this was our slope. Remember, we use m for slope. All right, and our point, we're plugging back into the original now. So back to this guy up here. So we get y equals 3 times 0 plus 1 times cosine of 0. Cosine of 0 is 1. This is also 1. 1 times 1 is 1. So our point is 0, 1. In other words, our y-intercept is positive 1. So if our y-intercept is positive 1 and our slope is 3, there's the equation of our line. That is answer choice C. All right, so in this episode, we looked at how to take the product rule And we also looked at how to apply it to tangent lines. And sometimes the product rule got a little tricky. So remember, it's first times the derivative of the second plus the second times the derivative of the first. There's our product rule. All right, tune in next time for the quotient rule.